In this video, we'll discuss how to inspect the various components on a manual transaxle. Once we have the input shaft and output shaft completely disassembled and we have all of our components out in the table, it's now time to start inspecting each of those components to see whether they're good enough to put back into the transmission or if they need to be replaced. Or if we're trying to diagnose for a source of noise, of course we're going to be inspecting these components to see what the root cause was. I'll start off with the output shaft. And so on the output shaft, and this is manufacturer dependent, many times they are going to want us to check the diameter of the bearing surfaces. This is the final drive gear. And so resting below the final drive gear is a roller bearing that runs on this race right here. And so the manufacturer has given me a specification. And so with that specification, I'll use my micrometer to measure the overall outside diameter of the bearing surface. And so I want to make sure that it doesn't exceed the minimum specification. And this one is well within the service limits. Now, when we're making these measurements on our bearing surfaces, or for really any measurement regarding the transmission, it's important that we remember how a component wears. So, take for instance the output shaft that we're measuring here is in a vehicle that has 250,000 miles on it. And the service manual gives us a specification plus or minus 0.010 of an inch. Well, when we measure the bearing surface here, and the measurement, let's just say that it is 1/1000 of an inch shy of being under specification. We have to ask ourselves, well, here's the range of my specification. The measurement that I made is within that range. So do I say, yes, that output shaft is good and put it back into the transmission, or do I replace it? Well, as this bearing continues to wear on that output shaft, its diameter is not going to grow. If anything, it's going to get smaller. And so if I am right on the outside of that specification, it's my opinion that we would want to replace the shaft. Just because I expect this transmission to last for another 200,000 miles if I overhaul it. And if it is just inside the wear mark, there's a good chance that it's going to go out of specification before that mileage is up. And then of course the transmission is back in my lap as a recheck. So I would make the measurement specifications that the service manual told me to. Make sure that they're well within the specifications. And then I pay close attention to the teeth of the gears. And so when we take a look at gear teeth, there's a couple things that I'm looking for. So this gear tooth represents what a good gear tooth would look like. We have to remember that when the transmission is operating, the gear is loaded in about that area that I'm shading in with the Sharpie. And so as I look at that area, I'm looking for pitting, cracks, any signs of wear. And this one looks really good. But then as I rotate the teeth around, I start to notice that some of my gear teeth have chipping on them. And so we can take a look at, let's say this tooth right here for instance. So we can see that there's a large chip right there out of the tooth. The same thing with this guy right here, another large chip in it. All right. Now, this chip was damaged by improper removal. In other words, the last technician that worked on this put it in that bearing splitter with the conical shape facing up towards the gear, and it loaded the outside of the gear and of course chipped that tooth away. Unfortunately, because of that, I'd have to remove and replace this whole shaft assembly. But let's say, for instance, that there was a small chip, kind of like we see on this guy right here. So this chip hasn't made its way into the working surface of the gear. So for this one, what I would do is I would take a little die grinder with a little grinding wheel, and I would simply round off any sharp edges that we had on there. Providing that was the only chip that we had, I would round that off, and then I would put this gear assembly back in the transmission. Remember, if the damage isn't on the portion of the gear that's taking the load, then it suffices to say that we could just chamfer down those sharp edges and then reuse the gear. So I will have measured the bearing surfaces to make sure that they're not worn out to the point to where they need to be replaced. I will have inspected the gear teeth to make sure that the chips and such weren't damaged or encroaching in on the working surface of the gear. The other thing I want to pay close attention to is the splines. The splines of the shaft are what's going to be taking the load when the transmission's working. And so I'm just looking for no damaged splines, and I'm going to do that for both the output shaft, and then I'm also going to do it for the input shaft. And we can clearly see that on this input shaft, when we take a close look at our second input shaft gear right here, if we zoom in, we can see that the teeth are completely chipped off. And so this represents a shaft where there's no way that we could throw this back into the transmission, because with these teeth missing and because they're right next to one another, as soon as we loaded that gear, they would just continue kind of the domino effect and breaking off. So, checking both the shafts, measuring my wear surfaces, inspecting the teeth, making sure that the splines are in good shape, and if that all checks good, from there I start inspecting the speed gears. Speed gears are the gears that are going to be engaged when we go from first to second to third to sixth, or whatever the case may be. And we can identify the speed gear because the speed gear will always rotate on a bearing and be able to spin freely on the shaft that it's on. The speed gear will also have the cone clutch. It'll have the dog teeth that the synchronizer sleeve will attach to. And then, of course, the teeth of the speed gear itself. So much like the input shaft and output shaft teeth, I'm going to inspect them for wear, chips, damage, and such. We typically don't see a lot of wear on our speed gears just because that speed gear is only in use when I'm in that gear. So if we think about it, we use first and quite possibly fourth the most often, because we use first every time we take off, and depending on how we drive, we're either going to be in fourth or fifth. So those gears will have the highest wear on the teeth. But where we do see wear is going to be on the dog teeth themselves. So on the speed gear, these are the dog teeth. The dog teeth are the portion of the gear that the sleeve is going to slide down on and engage when we shift into gear. The points of wear that we see are right here on the tips of the dog teeth. And so what I'm looking for on the dog teeth themselves is to make sure that they have this nice crisp point to them, that triangle that we see right there. When you grind gears, in other words, when you miss a shift, what is grinding is not the speed gear where it mates with its corresponding gear. What is grinding is the sleeve as it tries to engage. So on this speed gear, we can see that the dog teeth are very crisp, very sharp, they're in good condition. If we contrast that to this one, we'll notice how the dog teeth are all rounded off. We can see that sharp triangular point that was on this one is no longer there, and that they're all rounded. This gear came out of a transmission whose synchronizer ring had failed, and so as it was driven, the sleeve was constantly grinding on the dog teeth of the speed gear. So this one here represents what a bad speed gear would look like, because the dog teeth are worn. This represents one in good condition, where the dog teeth have nice sharp edges. Now, expect to see a slight amount of rounding on your lower gears, first and second. A slight amount of rounding is normal, providing that the dog teeth aren't completely rounded off and that they still retain a small amount of back cut. So on these dog teeth, the way that they're shaped is they're cut back a little bit. And that cut back in the dog teeth is what locks the synchronizer sleeve to the gear when the transmission is either on accel or on decel. I would also pay close attention to the cone clutch. So this transmission in particular, its synchronizer rings have a clutch material on the inside. That's this brown that we can see right there. Other transmissions may use a synchronizer ring that's simply made of brass. And others yet could have a synchronizer ring that has some semi-metallic lining on the inside of the synchronizer ring. Expect to see slight amounts of bluing on the synchronizer's cone, on the speed gear's cone clutch due to the friction that builds up as gear shifts are made. A slight amount of bluing on this is fine, but what we don't want to feel is any grooves or notches. So as I slide my fingernail over it, I want to make sure that I don't feel any grooving or any serrations or anything in it. So this cone clutch looks good. So from the cone clutch, the next thing that we need to inspect is going to be the synchronizer ring. And depending on manufacturer will depend on how the clearance for the synchronizer ring is measured. And so here's the synchronizer ring, and it slides right up here on the cone clutch. Cut. Okay. 3, 2, 3, 2, 1. So to inspect the synchronizer ring clearance, I've gone to the service manual and looked up the specifications. Insert picture of spec. The specifications tell me that the maximum clearance between the synchronizer ring and the dog teeth is 20 thousandths of an inch. So what I do is I get a feeler gauge, and I choose a 20 thousandths inch feeler gauge, and then I'm going to lightly press on the synchronizer ring and engage it to the cone clutch. Then, using my feeler gauge, I'm going to measure the clearance between the two. Now what I want to feel is no drag. 20 thousandths of an inch is the minimum clearance. And so if I put my feeler gauge in there and I feel drag, that is telling me that the synchronizer ring has worn out. When we think about synchronizer ring clearance, I want you to picture that the cone clutch is one triangle. So we've got a tapered surface there, it kind of looks like a triangle. Then when you think of the synchronizer ring, it is just the opposite. And so what we want to have is that a synchronizer ring that isn't worn, as it slides up on the cone clutch of the speed gear, there's still plenty of clearance between the end of the synchronizer ring and the end of the speed gear. But what happens is as the synchronizer ring wears, it allows the synchronizer ring to go deeper onto the cone clutch. And so as it goes deeper onto the cone clutch, that clearance, of course, is going to decrease. A great speed secret is to take the synchronizer ring, push it up onto the cone clutch, and give it just a little twist. And with this one here, what we can see is that there is no clearance between the synchronizer ring and the dog teeth of the cone clutch. This synchronizer ring is worn out. When you deal with brass synchronizer rings, what you will notice is that on the inside of the synchronizer ring are these little serrations, these little grooves. What you should do without a glove on your hand is run your finger across these. They should feel sharp, almost knife-edged. And as I slide my finger across these, I can feel that it is just butter smooth. The reason that it is butter smooth is because the knife edges of those little serrations have worn down. So if we think of these synchronizer rings as knife edges, in other words, these sharp little points, and the reason that they're there is so that when the synchronizer ring comes up onto the cone clutch, those knife edges cut through the oil that is between the synchronizer ring and the cone clutch so that it can actually grab that speed gear and speed it up or slow it down. But if the knife edges then get worn out and become flat, now it can no longer grab that cone clutch, nor can it cut through that film of oil to help grab that speed gear. And so that in turn leads to grinding, because now the cone clutch can't speed up or slow down that speed gear so that it can let the sleeve slide across the hub and engage the dog teeth of the speed gear. The next component we want to inspect is the hub. Now remember, the hub is the component that's splined to the shaft that the sleeve will slide over. So for the hub, I want to check the internal splines where they are attached to the shaft to make sure that they're not worn or damaged. I also want to check the external splines where the sleeve slides back and forth. On a hub that is worn, and this one is in good shape, and it's in good shape because the surface where the sleeve slides back and forth is nice and smooth. On this hub here, we can see that it's worn, it's grooved, and it's notched out. Remember, the sleeve has to slide smoothly back and forth across the hub. And so with this hub being worn, it would cause a very rough feel as we tried to engage the gear. So again, on the hubs, I'm inspecting the internal splines, and I'm inspecting the external splines for any signs of wear. And if there is, we should replace it. Another component that we need to inspect is the sleeve. And along with the dog teeth of the speed gear, the sleeve is another high wear item, because the sleeve is what's going to slide over and engage the dog teeth of the speed gear. So when we inspect our sleeves, there's a couple measurements that we want to make. Some manufacturers will have us measure the clearance here in the sleeve where the shift fork rides. I want to ensure that the shift fork doesn't have a lot of slop back and forth inside the sleeve. The other major point of wear are going to be on the teeth of the sleeve where it engages the dog teeth of the speed gear. Much like the speed gear, we're looking for a nice, sharp, crisp edge where the teeth engage the dog teeth. These are nice and crisp. We've got that triangle there. It looks good. And then as we inspect on the inside of it, we'll also notice a slight amount of back cutting there. Remember, that back cut is what holds the transmission and gear under accel and decel. And I can still clearly see that the back cut is there and that my teeth aren't rounded off. If we have a worn sleeve, it's going to look much like this one here. We can see that the sharp edges are no longer there. They've all been rounded off. If we flip it around to the other side, we can see that the teeth are rounded off to the point to whether it's even encroaching on the back cut. And so with our sleeve, if we see rounded teeth, we would also expect to see the same thing on the dog teeth of the speed gear, because remember, that's what's causing that grinding noise. And more often than not, worn teeth on the sleeve and worn teeth on the dog teeth are caused by synchronizer rings that have failed. The shift fork is another point of inspection, because the shift fork is going to wear whenever we slide the gear selector forward and back. And so when we inspect the shift fork, we want to pay close attention to where it contacts the sleeve. This shift fork has nylon inserts, and these can be popped off, and if we saw wear on these, we could replace them. And we'll snap him back on. Remember, the shift fork is what's going to engage the sleeve. So whenever I slide that transmission's gear selector back and forth, it's the shift fork that is moving the sleeve itself. That's why the clearance between the shift fork and the sleeve is crucial, because if I can't slide that sleeve far enough, there's a chance that it may not engage the speed gear, which could cause the vehicle to pop out of gear. When we inspect the shift forks, like I say, this one, it has these nylon inserts that could be replaceable. Sometimes they aren't. So this is an example of a shift fork that has excessive wear. And so we can see on the shift fork this shoulder right here. That shoulder represents the original thickness of that shift fork itself. It was rather thick, but because of wear, it has gotten thinner. A good rule of thumb for shift forks is if you slide your fingernail across it and you can feel any little ridges or signs of wear, the shift fork more likely than not needs to be replaced, because excessive wear in the shift fork means that it can't throw the sleeve far enough to completely engage the dog teeth of the speed gear. So along with wear, we're also inspecting to see if the shift fork is broken. So here's an example of a shift fork where one of the tines of the fork is actually broken off. And if that's the case, this transmission in particular couldn't be shifted into gear because with only one shift fork tine actuating the sleeve, it made it so that the sleeve would bind on the hub and not slide into gear.